Welcome to the imaginary world of complex numbers. This is the complex number unit. Here there are 4 goals that the student should be able to learn. 1. To use imaginary unit I to write complex numbers. 2. To add, subtract, and multiply complex numbers. 3. Use complex conjugate to write quotients of 2 complex numbers in standard form. And 4. Find solutions of quadratic equations. Here's a funny cartoon. The teacher says, "Why are you turning in a blank sheet of paper?" And the student says, "Because all my answers are imaginary numbers." It's funny because the notion of imaginary numbers are they can't be seen. But as we will see, imaginary numbers are just a way for us to write basically what a negative square root number is. That leads to what the unit summary is. Here it defines what the unit is. Some parts are some quadratic equations have no real solutions. For example, the equation x to the power 2 plus 1 equals 0. If you try to solve this, you're going to see that x squared equals negative 1, and you can't get that because there's no two numbers that you could square root together to actually get negative 1. Here, that's why this is the notation I comes in, and I equals the square root of negative 1. And I squared equals negative 1. So here it talks about the standard form of the imaginary number. In standard form, it is complex numbers using the imaginary unit I. Here the standard form a plus bi. Here they show how a regular number, negative 2 plus square root negative 16, is negative 2 plus 4i. And the way they go about that is, first of all, they get rid of the negative 16 here by taking out it to negative 1 here. They break it in half. 4 squared, which is the 16, and the negative 1 here. They break it into 2 parts. The square root of 16 becomes the 4, which is brought outside, and the square root negative 1 is still left within the square root, and which is going to equal the I in here. You note this is how they get a complex number. Here on the left hand side, you'll see sort of the flow on where the complex numbers come to play in the grand scheme of things. First of all, you start with your natural numbers. Those are your 1, 2, 3, 4. Sometimes 0 is included. That's also called the whole number. Then once you start adding the negative numbers, you get your integers. When you start dividing numbers like 1 over 2, 3 over 4, you get your rational numbers. Irrationals are basically numbers that can't really divide correctly, like 1 over 3, that's like 3.3333333. And if you combine all those together, you get real numbers. That's what basically students have been working with. Once you get the square root of negative 1, you get your imaginary numbers. This is what this unit is, and together you get your complex number system. Here you see graphically what an imaginary number is. So sort of that is basically the nutshell of what the unit is supposed to be teaching here. Here you could see the quick video of what complex numbers are. And the subject area, most classes teach this in Algebra 2, but also in pre-calculus, the complex number system. The grade level is 9 to 11. So there are 4 activities here. There are 1, the teacher lecture with guided notes, the web assign with a poster project, and graphic organizers. The problem sets are actually will be given as homework for the students, as well as can be located in the unit resource links here. On the bottom you have some content standards, but mathematics builds on top of each other, so a lot of the previous standards will carry over here. Here you have the big idea of what the complex number system is. I think the 3 biggest objectives here for students are students will be able to understand how and why complex numbers are created. They will understand how to write them and apply them into polynomials, as well as use some basic operations of complex numbers. Okay, so some questions we want kids to be considering while going through this unit are: what are complex numbers? How do you write real and complex numbers? And what does it mean? What does it represent? And what can I do with these numbers? Can I add, multiply, subtract, divide? Okay. So the first thing is the assignment. The assignment, um, first of all, the assignment starts with a last chapter test correction, which is students will go over basically their previous chapter, making sure that they get what they need from the previous chapter moving forward, because math builds on top of each other, so students will need that. So that is sort of the entry-level assessment for this. Next, you have the flashcards and standard question format. Here you see it asks what type of function it is. F of x equals c, which should be a constant. Yeah, and there's other, like, what is x squared? I think that is a squared function, as well as this should be a quadratic, which is standard form, things like that. So this is a good formatting of flashcards students can go over to get the terminology and the language and the vocab that will be used. And besides flashcard method, students here have a basic question format here. What type of polynomial is this? That should be a linear, right? Here, let's check the answer. That's a monomial. Okay, because it's one term, things like that. So this is a good way for kids to test prior knowledge as well as vocab. So this would be your formative assessment here. The two big things here in the summative assessment is the poster project as well as the essay assignment. These are actually made by myself completely with no external sources. So yeah, these are just made by me here. The poster project details what elements the kids will have. You can download and see it. And this is the essay assignment. A lot of people will criticize, why make kids write an essay in math class? It makes no sense. Essays are supposed to be for English class. No, I think essays are there to help kids sort of guide their thinking process in mathematics. When you ask a kid, hey, can you explain the problem? And they're saying, well, I did this, but they never explain it in sort of good enough logic in terms of progression of thought process. So this essay should should teach kids and allow them an assessment for them to engage that. Here is the summative assessment rubric. Here, all files can be downloaded if you want to see that. The teacher lecture is actually what I'm most proud of. Here, the reason why SlideShare was used over Prezi is because SlideShare, I use the PowerPoint because PowerPoint is the only way I could write any equations. Prezi wouldn't allow me to that. This is a good lecturing for students to go over. There's warm-ups, brief introductions. It goes over all the different steps on how to solve and the operations. So this should tackle all the standards within the presentation. Here you have the videos. The autos are enabled as well here. Here are the guided notes of the complex numbers as well here. You might not hear this, but you see that the videos do work. Things like that. Now the WebAssign. The WebAssign one, you can download it as a PDF right here where you download the WebAssign, but also I broke it down into small parts and kids can actually go to the site, and these are sort of the different modules within it. There are 6 modules. The 7th one is the poster project. Going over it, module 1 is accessing prior knowledge. 2, a graphical model. 3, the origins. Module 4 is the notation I, which takes the historical point of view. 5 and 6 are just basic operations that kids are going to do. And 7 is the poster project as well. As you note, this the assignment here of the poster project here is the same as the WebAssign poster project here of the laws of complex numbers. Third is the graphic organizer. The graphic organizer is aimed to actually teaching students high order thinking. They work because they help make high abstract mathematical concepts, informations into representation form. Students will learn the ability to organize and categorize complex mathematical concepts. Moreover, they will apply rules of logic towards the concept to enhance their learning process. The first one is a flowchart. Like I said before, about how numbers, there are different operators flow within each other. I think this activity will allow kids to explore that more. Uh, Natural numbers will fall under integers, integers fall under rational numbers, then they would get to the complex numbers as well. This is all made by me as well. Next is the compare and contrast matrix. When this whole chapter within the book deals with polynomials and how to solve for polynomials. Here you break down the 3 different methods that were presented within this chapter, and kids are given different polynomials right here, and they're gonna sort of describe what method is best, what method can be used, what method can't be used as well. So this is a overall good process for kids to make headway in terms of what method should use and what method should not be used. Here is the example. I completed this myself. So this is sort of what the kids can refer to if they need guidance, and as well as the rubric is down here. So the best part is the unit resource section here. You have some videos as well as practice problems for the videos. Let's look at complex number calculator steps. This is actually the most beautiful part. Here you can actually calculate how to solve. So if kids are stuck within their homework, they can actually come here and calculate it out as well. You have your simplifying complex expressions here as well. So you can do that. This is a good way. Different tools, online resources kids can use. And let's see. Here it says, well, and here are the 2 problem sets. These are the short and long version. The short version is if a kid needs like some extra practice before a test, and this is if a kid really wants extra practice, as well as if a kid misses the problems in class and needs work, or they're absent that day. I will assign these. The funny part is I will actually use these problems on the test. So and there's different note resources. Here you have the right here notes of the complex system kids can use, as well as a PowerPoint presentation here that I made of complex numbers, right? So kids can use this as well. So there are different notes resources as well as online resources digitally kids can use. Then there's also the complex numbers on how to use the graphics calculator. Lastly, you have your teacher website. This is where kids can actually go to my teacher website. Then they can actually come back. So yeah, this is overall the imaginary world of complex number unit. It has allow kids to explore different aspects of complex numbers and where they come from. A lot of tools. These are all besides the rubric. The rubrics I used in online resources, but besides that, all the poster projects and the assignments and the problem sets are all made by scratch from me. I believe that's necessary because I want to make sure kids understand these ideas. I think the beautiful part about the website here, it's broken into different modules that kids can actually do over a given period of time. But besides that, yeah, this is basically it. This is the Mr. Brian Cybermuck's Imaginary World of Complex Numbers. Hope you guys enjoy.